So the material provides this incredibly detailed planet-by-planet catalog of all the extreme and lethal environmental conditions across our solar system. Everything from Mercury's temperature swings to Neptune's supersonic winds.
And the research foundation is it's incredible, really solid. You can tell a huge amount of work went into detailing exactly why you can't survive out there.
Absolutely. So the task now isn't about the facts. It's about how we present them to maximize the drama, the impact.
Exactly. The facts are lethal, we know that. But presentation is what fulfills the promise of a piece like this. You know, you're not reading a scientific paper. You're on this journey of unavoidable doom.
Right. We need to make sure every single stop on that journey delivers the dread.
Uh-huh.
So let's dive into the architecture. I think the biggest opportunity here is in how we organize this amazing data set to build that momentum.
Okay, yeah, I completely agree. Organization. While the sequential, planet-by-planet structure is logical.
It makes sense. Mercury to Neptune.
Of course. But I think reorganizing the whole thing around the type of lethal threat would create a much more engaging narrative. You'd get these dramatic comparisons.
The weakness right now is that the current structure, it kind of creates this narrative exhaustion, doesn't it?
That's a great way to put it.
You hear about extreme cold on Mars. Then you hear it again on Jupiter, then Saturn, Uranus, Neptune. It's like hearing the same chord played over and over.
It loses its shock value.
It does. It risks feeling less like this escalating journey of demise and more like a scientific catalog. And despite the horrifying facts, that structure just diminishes the punch of the later threats.
It's narrative fatigue, exactly. By the time we get to the immense cold of Uranus, the listener might just unconsciously file it away as more of the same, even though the conditions are uniquely horrific.
Right.
So the suggestion is to group the planets not by their orbit, but by their primary, most vivid way of killing you.
So you get to compare the different death experiences.
Yes, you can compare a crushing death versus a freezing death versus a radiation death. That builds a really compelling sort of comparative drama across the whole solar system.
Okay, I like that. But I wonder, if we jump from, say, Mercury straight to Venus under a heat heading, are we worried about losing the geographical flow? Does that confuse people?
I don't think so, because the dramatic contrast is just so much stronger. The audience is here for the how you die part, not the solar system tour.
Good point.
So we could, for example, create a section on, say, thermal extremes and surface challenges.
Okay.
And in there, you juxtapose Mercury's violent swings, 430 Celsius day to minus 180 nights.
That thermal shock, that would just shatter anything.
Precisely. And you put that right next to Mars's rapid but, less extreme daily crash from 20 C to minus 130 C. The threat is framed around the inability to cope with instantaneous temperature change.
And then you could follow that with a section on crushing pressure and acidic toxicity.
Exactly. And that's where Venus just gets to shine in its own horrifying way.
It stands alone as the ultimate pressure cooker.
It really does. Venus gives you that terrifying, immediate crush death 92 bars. That's like being 900 meters underwater. You're not just compressed, you're crushed and basically dissolved at the same time in sulfuric acid.
And then you could contrast that immediate surface death with the slow burn pressure death on Jupiter.
Yeah, that's a great contrast. The Galileo probe lasted, 58 minutes? As the pressure and temperature just ramped up, turning hydrogen into a metallic liquid. It's the difference between instantaneous failure and this guaranteed slow descent into oblivion.
Love that. And a final section, maybe something for the invisible killers.
Radiation and unavoidable force.
It's an invisible, instantaneous killer for both biology and electronics.
Mm-hmm.
And you can contrast that with the more steady, long-term surface radiation on Mars, which is maybe 40 or 50 times higher than Earth's because it has no magnetic.
So that one structural tweak, it takes the same fantastic facts and just deploys them so much more strategically.
It turns a catalog into a thriller.
Exactly. A high-stakes thriller that keeps the tension up the whole way through.
That's a huge change, and it leads perfectly into our second piece of feedback. It's not just where we put the facts, but how we make them land.
Right. It's about making the numbers feel real, making them hurt.
Precisely. This is about angle and originality. It's about fulfilling the dramatic promise of that title. To fully deliver on how you die, the material has to move from just describing the environment to vividly illustrating the immediate physical mechanism of failure.
Yeah, the source material right now, it leans really heavily on those technical stats. We hear that pressure and temperature increase rapidly, or, NASA spacesuits can handle temperatures up to 121 degrees Celsius.
Important facts.
Crucial data points. But they kind of miss the opportunity to translate those numbers into a visceral, immediate consequence for the listener. We know what the environment is. Now we need to know exactly how it kills us.
That gap between the number and the nightmare, it's there even in the most hostile environment. So the suggestion is to anchor every scientific data point directly to the immediate human scale. Detail the specific failure mode that the condition causes.
Make it graphic.
Yeah, keep it in that high-stakes tone. This is what fulfills the listener's expectation. They're here for the dramatic narrative, where the numbers lead to an instantaneous, physical result.
Let's get concrete with this. Let's make it actionable. For Venus, for instance, instead of just noting the pressure is 92 bars.
And the 9 football fields deep in the ocean thing.
Right. We need to describe the pressure suit failing. The source says it would fail within seconds, but we need to show that, emphasize the sound, the sharp, violent crack as the structure just implodes.
Crushing the occupant.
Instantly. And then you immediately layer in the sulfuric acid clouds. You focus on the instantaneous physical decomposition. The listener needs to feel that total, complete system failure.
Okay, and for Mercury, we've got that incredible fluctuation at the terminator zone, where day meets night.
Where conditions shift too fast for anything to survive.
We have to use that. Instead of just stating the temperatures, describe the catastrophic thermal shock, that instantaneous jump from 430 degrees C to minus 180. This isn't just uncomfortable. It's an explosive, material-rending event. You could describe the ship's hull buckling, metal screaming under the stress of that sudden contraction, the internal systems all seizing up. It's total, catastrophic thermal failure.
And Jupiter. Jupiter is the perfect place to make an invisible threat palpable. We have to go beyond just lethal radiation.
Connect that 20,000 times stronger magnetic field directly to the failure.
Exactly. Detail the sequence. First, the navigation systems just blink out. Then life support shuts down completely. All while these invisible forces are, tearing through your biological matter at a cellular level. It's a silent, instantaneous biological destruction from an invisible force field.
That's so much more dramatic than just citing high dose rates.
By injecting that visceral cause and effect, the listener stops just learning about the planet and starts, experiencing its deadly nature.
You're translating physics into terror.
Absolutely. And that dramatic focus brings us to the outer solar system, where the narrative challenge shifts quite a bit.
Right. Our third critique is about completeness and focus, specifically differentiating the 4 gas and ice giants, Jupiter, Saturn, Uranus, and Neptune.
The science in the material here is fantastic, but we have to make sure that the ultimate lethal threat on each of these planets is distinctly isolated and foregrounded.
Or else what happens?
Or else the narratives for Saturn, Uranus, and Neptune, they all risk blending into this generic descent into hell story, where the wind speeds and the pressure just keep going up.
That is the core weakness, yeah. None of them have a solid surface, so the story shifts from landing to descent, and the descriptions can get very similar. Internal heat, high pressure, crazy winds.
No survival beyond the upper atmosphere. We get it.
And the really unique, specific threats, like the bizarre physics of Uranus or the sheer speed of Neptune's winds, they get kind of overshadowed by this generic gas giant death.
So the suggestion is simple. For each of the outer giants, highlight the single most defining and unique lethal factor that separates it from its neighbor. This is where we show that every death in the outer solar system is, bespoke.
Okay, let's start with Saturn. We know it has insane winds, up to 1,800 kilometers an hour. But like you said, high winds are kind of a staple for gas giants. So what makes Saturn's death unique?
It's context, the system around it. Saturn's unique killer is the sheer mechanical challenge of the system itself.
Navigating it.
Yes. We should emphasize the unforgiving precision you'd need to navigate the 146 moons and that vast, intricate ring system. The rings are just ice and rock and dust. Trying to pass through that is guaranteed catastrophic collision before you even feel the winds.
Or see the giant hexagonal storm at the pole?
Exactly. Saturn's unique hazard is the approach. It's death by an external debris field.
That's a great distinction. It frames the danger as external and kinetic, which is totally different from Jupiter's internal radiation field or pressure. Okay, powerful. So now the ice giants, Uranus and Neptune, they're always so hard to separate.
They are. They're chemically similar. Hydrogen, helium, methane. They both have diamond rain. But Uranus has that bizarre, unique physics from its 98-degree tilt.
It's rolling on its side.
We need to focus on that. We pair the incredible diamond rain phenomenon, where carbon atoms compress into solid diamonds, with its 900-kilometer-per-hour winds. We betray Uranus not just as cold, but as a freezing, pressurized, crystalline grinder because of its skewed rotation.
It just feels uniquely chaotic. A crystalline grinder. I like that. That successfully shifts the whole focus from a generic, cold and windy narrative to a very specific, unique mechanism of physical destruction.
And that just leaves Neptune. So if Saturn is a precision failure and Uranus is a cold grinder, Neptune has to be about sheer, raw, kinetic speed.
That's it. We isolate its defining threat as the velocity of the atmosphere, the fastest winds in the solar system, reaching 2,000 kilometers per hour.
Faster than the speed of sound.
Significantly faster. We have to focus on the terrifying physics of how that supersonic speed interacts with its massive dark storm. The other giants have big storms, but Neptune has supersonic massive storms.
So its danger is a pure kinetic force unmatched anywhere else.
Right. By creating those sharp distinctions, Saturn is the navigational obstacle course, Uranus as the skewed crystalline freezer, and Neptune is the supersonic velocity killer, we make sure the end of the narrative is just as sharp and exciting as the beginning.
Every planet gets its defining moment of unique doom, and the listener doesn't get that narrative fatigue we talked about.
These are really the high-level shifts that will transform what is an excellent research-heavy document into a truly captivating narrative. It's all about restructuring and deepening that emotional impact.
And I just want to reiterate, the underlying research is genuinely superb. All the specific facts are there to support this level of drama. You have all the raw material you need.
Okay, so to quickly recap the three main actionable suggestions. First, reorganize the material by category of lethal threat: thermal, pressure, force, not just chronologically.
Yep, address that structure and flow issue.
Second, deepen the description of the immediate visceral failure mechanisms. Move beyond the stats and illustrate the instantaneous physical collapse, the decomposition, whatever it is.
Fulfill the promise of the title. Nail that angle.
And finally, when you get to the outer solar system, isolate and foreground that single, unique, defining fatal characteristic for each of the outer planets.
Whether it's Saturn's rings, Uranus's tilt, or Neptune's winds.
Exact. Give each one a distinct focus.
Implementing these changes will ensure maximum impact, and it'll make every planet's deadly environment distinct and unforgettable. We really look forward to seeing the revised version.
Thank you so much for sharing your work with us. We invite you to make these revisions and submit the material back to us for another round of feedback soon.